Okay, so when we talked about 2C.14, we were talking about how it is very much calculator heavy, but it's also centered on making sure you understand how to set up and create equations. So in 2C.14, it's our function models. And the typical log function, I'm sorry, I don't know why I'm going back to it. The typical log function model is going to be y equals a plus b log x, okay? Because you are using Desmos, you can do the setup and solve in Desmos. Like, that's the beauty of it. But they're going to still want you to be able to write it out and say, okay, this is what, if I didn't have Desmos, I know I would have to do this. Does that make sense? All right. So when we look at this one, this is pretty straightforward. This is a regression example. Do we need to go back over the steps of how to put a regression model in, or is it more important for me to do example 3 where you have to set up the equations? Okay. So again, we're all comfortable with Desmos, right? Doom, 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 doom. Okay. Oh, no, I did need to cover this one. This one, you can't just use the regression model. So you know how Desmos has those drop-down models? This is where you have to actually type in the regression model that you want. So notice here, it says this is the format that it wants it in. It wants it in a plus b natural log of p. You have to insert this into Desmos yourself. By inserting that into Desmos, that's where we go back to Algebra 2, where we learned about y sub 1 tilde. Do y'all remember doing that? And we have our a plus b natural log of x sub 1. Okay? You have to input this instead of doing the drop-down regression model. Okay? That's because there's a specific format that it wants for you to find. So because of that, when we type it in, and I'm probably best if I actually go ahead and do it. Okay, so we're going to add our table. We're going to type in our values. So in this case, we have 75, 120, 250, 300, 450, 650, 900, 1500, 2500, 5000, 5,000. And then on our Y's, 42, 58, 70, 79, 88, 95, 110, 125, 138, and 175. Okay. Again, we can zoom in so we can see our features. We can see that it is creating a log shape motion. Now, if you use this right here and you go over here to log, it does not give you the option for natural log, does it? It only gives you the option for regular log. It does not give you the option. Notice that my log mode's already checked, but it doesn't give me the option for that. However, what I have learned is that because of the newer ones, it sometimes will set it up automatically, and which is really nice. If it sets it up automatically and it decides that a natural log is the best model for this, then we don't have to type in that. So in this case, all the features have been updated. I love it for you. You're lazy. You don't do diddly squat. Yeah, it just gave us log at first. That's crazy. So they just keep updating it to make it easier for you on the test. No, I feel like College Board is giving it to y'all. Yeah, no, there's no challenge in this. Yeah, this wasn't here last year. Last year they couldn't do this, so they weren't able to just do that. Which is an unfair advantage. Crazy. All right, I don't like it. Feels weird. But anyways, apparently you don't have to worry about typing in the tilde. Yeah. Because they had at first at log base 10, it was just regular log only, which was a times b to the x, and that meant a. That's it. Tragic. Interesting. All right. So if you get this problem wrong, it's on you. There's no reason for you to get this wrong, like at all. If you get this wrong, do not blame me. If I do not see 100% understanding when I get my teacher report back on this content, on this subject, we have a problem. Like, you just had to type numbers in. And do what else? Nothing. Your hand slipped? No. All you do is type in numbers. And then it says, use the model found in the part A. What is the predicted annual salary if you have 500 people? Well, they even made it where you just got to copy it. And now once you copied it, you click on the gear, you open the table, and you type in whatever you need. I need 500 people. And what does it tell me? It's going to be roughly 94.329. That would be his salary, about 94,000. Okay. There's no reason why you should get any of this wrong. All right. Anymore at all. Ugh. I'm so serious, guys. If I don't see 90% plus on this, we're fighting. All right. Next one is when you are calculating log. This is where you're going to have to type it because there's apparently now, instead of it giving you log base 10, it gives you natural log. So notice here that this is not natural log. This is common log. And now the regression is set to do what? Natural. So your regression in decimals is set to do natural, which means that you are going to have to type it out for common. Does that make sense? So let's kind of go over it here. It says the most common and preferred method to measure sound intensity level is in decibels, dB. The sound intensity level beta, in decibels of a sound having intensity I in watts per meter squared is modeled by the function beta of I equals A plus B log I, where A and B are constants. The sounds of noise traffic has an intensity of 1 times 10 to the negative 5 watts per meter squared and corresponds to 70 decibels. A loud concert has an intensity of 1 and corresponds to 120. So based on what you have here, you can create your own table, your independent variable versus your dependent variable. Your independent variable is what's inside of the parentheses. Inside of the parentheses is our I, our intensity, right? So our X values are going to be the values of intensity. So this is, got a little weird there. So this is a value of intensity, and this is a value of intensity. So those are going to be your independent variables. So we have 1 times 10 to the negative 5, and we have 1. Your output variable is going to be your beta. Your beta is your decibels. So we have 70 decibels, and we have 120 that corresponds to the previous mentioned intensities. So we have 70 and 120. Those are your two values to start your regression model with. Okay. Now it wants you to set up those two equations. So yes, can I use Desmos to check myself? Why, yes, I can. But it wants you to create those two equations yourself by giving you the beginning. When you're creating, bless you, when you're creating those two equations, you need to use the variables that are given to you. Does that make sense? So you're using beta and you're going to use I. So if it gave me beta and I, that's when I'm creating those two equations by. So we know that our B of I, so when we have beta of 1 times 10 to the negative 5, it equals A plus B log of 1 times 10 to the negative 5, which equals 70. So that's my first equation. The next beta I have is 1. Beta 1 equals A plus B log of 1 equals 120. You will not get points for this problem without these two set up. I do not care if you use the calculator to check yourself, but it needs to show that you can calculate this without it. Okay? When you're finding the values of A and B, it is always going to be the elimination method. Okay? So your job is to eliminate. Change colors. So we're going to be using the elimination method. Using the elimination method means that when I'm combining these two, one is going to have to be subtracted, right? If I don't, then I'm going to end up losing those values. The other thing here is I can actually simplify this. Log of 1, what does that give me? Just type it in. Tell me what log of 1 is. You should know what it is without typing it. But tell me what log of 1 is. 0. It is 0. Log of 1. Any base log of 1 is going to be 0. That's because any base to the power of 0 is 1. Okay. So 10 to what power equals 1? 0. So therefore, if I see log of 1, I know that is 0, which means that it eliminates this b for me. And I automatically know what my a is. Does that make sense? So here, that eliminates. So this becomes a plus b log of 1 times 10 to the negative 5 equals 70. And this becomes a equals 120. And that's because log base of 1 is 0. So I've eliminated the b, which now just simply leads me to substitution. Now that I have substitution, I know the value of a. Can I solve for the value of b? So we have 120 equal, I'm sorry, didn't mean to put the equal sign, plus 120 plus b log of 1 times 10 to the negative 5 equals 70. I'm going to subtract 120. And we get b log of 1 times 10 to the negative 5 equals negative 50. And the last thing to do to get b by itself is to divide by log of. Now we're at the point where we're finding the values of a and b. We know a is 120. And now to find b, we're going to plug in negative 50 divided by log of 1 times 10 to the negative 5. So when I come over here, I'm going to refresh so I can clear this all away. And I have negative 50 divided by log of 1 times 10 to the negative 5. And what do I get? The answer is simply 10. So the value of my b is 10. That is the extent of what they would expect you to use the calculator for, because you should be able to show it. And now you have found the value of a and the value of b. Okay. If you didn't trust yourself, then that's where you would use your Desmos to double check that you did it correct for this FRQ. Remember, for each FRQ, you have roughly 15 minutes to do. Okay. So I can create my table. Like, okay, I wasn't sure if I did that math right. Let me check myself. 1 times 10 to the negative 5. And that was at 70. This is 1. This is 120. I'm going to adjust my window. And I cannot run a regular regression because it's natural log now. So I do have to use good old faithful a plus b log of x. And was I correct about set values? Yes. Okay. Again, these problems aren't, your FRQs with the setup the two are not meant to be what you miss. Okay. This is not the calculator question that calculator FRQ that I anticipate is missing. Because one, I can check myself. So I can do all the work and then I can still check myself to verify that I got that correct A and B. Does that make sense? All right, so now you have that, you've confirmed it. So if it asks you, the third part's gonna always ask you to use that model and figure it out. So it says, well, what if your intensity level is 1 times 10 to the 4? So when I write my equation, if I write it as f of x equals, and we know that we have 120 times 10 log of x. I now set it up for me to find that value. So if I can look for f of 1 times 10 to the 4. And it's going to tell me that that would be 4,800. Okay. So this is a tool that is meant for you to do well. You just have to remember how to accurately use it. Okay, and that was the last part of 2C14. I feel like they're giving you access to Desmos. Yes, but you still have to know how to use it. It's not going to just automatically spit out, and they're going to want you to be able to show your work that leads up to what you're putting in Desmos. Does that make sense? All right. Questions, comments, concerns about either types of ways that we may end up using Desmos. Setting up as a regression, we've learned that Desmos is going to automatically fall into natural log. If it's a regression other than natural log, we will have to use old school typing it ourselves, right? But as long as it's natural log, we're golden. And setting up the two equations, we find out what's our independent and dependent and plug them in correctly. Capiche? All right, so you were supposed